For experiment number 1, this is just introduction, and we just need to read. The objectives of this experiment is to know what kind of equipment you will use on campus and at home lab. Of course, you may not go to the lab on campus, so you will need to know the equipment at least, and you need to know the equipment you will use at home. You need to know the general lab policy, as I explained before. It is at the end of this lab manual, so you need to read it very carefully. You need to also know what is required for each lab, as I said before. As I said before, there is 10% for each exercise and 25% for the formal lab report for experiment number 9. This is just a minimum knowledge you need to know about before you do this experiment, that you know what's the voltage, what's current, what's the voltage source, and so on. These are the equipments that we will talk about in this experiment, including a software called waveforms. Under lab work, you will see all the work that you need to follow. You need to do all this in the lab. Okay, and at the end, there's exercise, the word exercise. Exercise may have exercise that you need to submit, or it will be included in this lab work. So, for example, here there's no exercise or anything. You just need to read. The first part here, sorry, is equipment on campus. For example, we have something called Agilent DC power supply. This is a device called the DC power supply, and there will be some explanation for this device on this file. You will find it on Canvas. So this is just a device that will be used to, for example, generate voltage, DC voltage or DC current, and this is up to 25 volt. If you see here, this is 25 volt. This one is 6 volt. So you may use it to generate up to 6 volt or up to 25 volt. The second device is called Agilent digital multimeter. Multimeter is a device that is used to measure voltage, measure current, measure resistance, measure some other elements like capacitance and so on. So this is a device that exists in the lab. And you will find the file called 34401A. This is on Canvas that explains how this is working. Next device is a function generator. And the function generator is a power supply, the same like the previous one, but the previous one was a DC power supply. This one is a function generator, which means that it can generate any wave. For example, sine wave, square wave, and so on. Like, for example, here you see you have, for example, here you have a sine wave, square wave, rectangular, and so on. This is a function generator. And you will find also a file called the Agilent 33120A on Canvas that explain this device. The first one is an oscilloscope. And the oscilloscope is a device that is used to display the signal. If you want to display, see how it looks like. Okay, this is a job of the oscilloscope. And you will find also a file called MSO3034 on Canvas that explain how it's working. Okay, so if you look at this, you have in these 4 devices here, you have 2 power supplies and 2 for measurement and display. So there's one, like this one here, is a DC power supply. So this power supply for DC. And the third one is a AC power supply. And then you have 2 for measurement. This one here is a multimeter, is to measure voltage or current or whatever. And the fourth one is to display this voltage and current. Okay, so 2 to generate voltage and 2 to measure and display. For at-home lab, you have this equipment here. You have this portable digital multimeter. The portable digital multimeter is one that is very similar to the one in the top here. This is a digital multimeter. So it is the same like this one, but of course it is not as expensive as this one here. Okay, so the digital multimeter, every one of you should buy one because we will use them in the at-home lab. So the digital multimeter look like this, but may have some different shapes, of course, and it will have some knob like this. This knob can be changed. Here it is off, for example. Here, this is the AC voltage. So if you want to measure AC voltage, here it is. If you want to measure DC voltage, look like you have to move the knob to this one. Or if you have a voltage that is millivolt, small voltage, you have to move it to this one. If you want to measure, for example, resistance, if you want to measure capacitance, if you want to measure current, and this is one's current, this is high current, and this is low current, and this is lower current in microampere, and so on. And this is temperature. So if you want to measure, do these measurements, you have to use this multimeter. And you have to be careful when you use the multimeter. Two steps are very important here. Number one is to move the knob to the right position. Assume, for example, that I want to measure the resistance. So the resistance, I have to move the knob to ohm, to this one, ohm. Okay, and then after that, you need to connect these two probes to the right positions. So this is the common. You see this common. Okay, so you connect the black to this common. And the red, you connect it to the right one. You have three here, 1, 2, 3. And this may be different from one multimeter to another. Maybe you have only two, I mean, two positions, or 3 positions, or 4 positions like this one. But at the end, all of them, the concept is the same. So for example, here's the top here of this one. You see here V, and this is omega or ohm, and this is C. So this, if you want to measure voltage or resistance or temperature, you have to use these two, the common and this one here. If you want to measure current, microampere or milliampere current, you have to use these two. If you want to measure ampere, high current, you have to use these two, the common and this red here. So that's it. This is how you use it. Okay, first you have to select, move the knob to the right position, and second you have to select the probes, the positions of the probes. Next one here is called analog parts kit. This analog parts kit is the or the box that has all the equipment or all the tools or components that you need in this lab. So you see here, if you look at this shape here, it has, or this figure, it has all the components that you need for this lab. For example, you see, I don't know, this one is not clear, but you see here, for example, this is IC, this is sensors, this is resistors, potentiometer, transistors, capacitors, LED, diodes, and so on. You will find everything on this analog parts kit. You will find also this white board here, we call it breadboard. You will find integrated circuits like this. You will find a screw like this, and so on. You will find also wires. Okay, so everything, all the components that you need to make the circuits are in this box. Next one here is called Analog Discovery Board, or ADB. This is the board, how it looks like. So it has some wires, cables like this. Every wire has a color. And in the other side, it is connected. It has a cable that connect to the laptop or computer. USB cable to connect to the computer. And this device is a device that we will use to do all the experiment, to do the measurement, real measurements. Okay, it simulates the 4 equipments that we explained before. So it has inside multimeter, it has a DC power supply, oscilloscope, and function generator, all of them. Okay, but of course with some limitations. It's not perfect, but this one is not expensive. I believe it is maybe $200 or something like this. And at the same time, it replaces all the other equipment that cost more than $10,000. So I encourage everybody to buy this analog discovery board and use it not only in this lab but also in other labs. You can use it even after after you finish this course, after you graduate. Okay, you need to practice at home anytime. You can use this one. So exactly here, as if you have a lab at home, real lab at home. And this not only that, you will see also the other advantages of this analog discovery board. So if you want to buy, you need to buy these two together, the analog discovery board and analog parts kit. You can buy them together, okay, to do this lab. There is a software that is associated with the analog discovery board. So when you connect it to your computer, you must have this called waveforms, waveform installed in this computer. Okay, there are some versions of waveforms. One for 32 bits, one for 64 bits, one for Apple. You will find all of them on Canvas, all the files on Canvas, or you can find them on the website of the company, Digiland. It's called Digiland website. Okay. Then you just need to install the right version that fits your computer. Okay, so this, for example, the traditional one look like this. This is the window of the waveforms, and this is a new one look like this. I personally prefer this one, but they are almost the same. There's no difference. There's no difference. But when you look at the window for the waveforms, what is this? It has a scope. This number one here is a scope. You see, this is a scope, so it has oscilloscope. It has a wave generator. This is a function generator. It has a voltage. This is a DC power supply. And it has also network analyzer. We don't have this in the lab. We have it in other labs. We have voltmeter. This is multimeter, but measures only voltage. And it has spectrum analyzer. This is also a different device. Okay. It has also a digital analyzer, patterns, and so on. So it has some stuff with digital here. So all these equipments are in one small package. It's one small package, very small. It looks like this, as very small one. Okay, that's why I encourage everybody to buy it, because it actually worth a lot. It worth a lot. Second part here, or second software, is called the B2 Spice, and the B2 Spice is also software that's used for simulation. So it's very important that you install it. So in your computer, you have to install B2 Spice and waveforms. B2 Spice, you will find it also on Canvas. Okay, it's called B2 Spice or B Spice. Maybe it is a zip file. And you will find also a software for waveforms. You need to install them. You're supposed to buy analog discovery board and analog parts kit to do the lab. Okay, and you need to buy multimeter, any multimeter. There are some multimeters that are very cheap. You don't have to buy a fancy one. This one I believe that's around $32, but there are some in Walmart, in Harbor Freight, in AutoZone, in many places. Okay, so you can buy any one you like, but it's better to buy digital one. Okay, so this is all what you need to know to know the lab. The next part in this experiment is a general lab safety policy, and as I said, you need to read it. Here I said it is on Canvas, but it is actually on this manual. So if you go at the end of this manual, you will find this general lab safety policy. At the end here, the last part is explaining what is required after each experiment. It's very important that you read this carefully. So as I said before, at the end of each experiment, number 1, number 2 to 8, and number 10. So number 2 to 8 and number 10, you will find exercise. In some experiments, the exercise are embedded into the lab work. Okay, so these 8 exercises have to be solved and submitted in a Word document file. All work in the exercise must be supported by any required calculation. If you have to do some calculations, and you take pictures for the circuit you built and any simulation you did and any results you have. Okay, so you have to support your document with all these pictures. It's very important. For experiment number 9, you must submit a formal report. As I said before, this is a 25%. Okay, and the format is explained here in these steps, and there is a sample at the end of this document, this manual. So first you have a cover letter and table of contents, then you write the objectives of the experiment and so on. So you need to follow this format. So again, this is a note. Each exercise counts 10% of the final grade, and the formal report for experiment 9 will be 25% of the final grade. So you have 5% bonus to substitute for any points you lose in any exercise or the formal report. Next time I will talk about experiment number 2, which is the PTU spice. Thank you very much for watching.